In an electronics program, it is vital to understand the basic electronic components. These components form the foundation of a circuit, and their proper connection and use directly affects the performance of the circuit. Next, we will introduce some common electronic components and learn how to effectively use them in circuits. Jumper wires are wires used to connect different parts of a circuit. They are commonly used in circuits such as breadboards, electronic prototyping boards, etc., to easily connect different components. Jumper wires usually have a protective coating, which needs to be stripped using wire strippers in order to connect them to the circuit. Stripping jumper wires usually requires the following steps. Estimate the length of jumper cables required and cut them with wire cutters. Depending on the size of the jumper cable, select the appropriate notch on the wire strippers. Allow about 1 to 2 centimeters from the end of the jumper cable. Align the slot on the wire stripper and press down firmly on the stripper to remove the insulation from the jumper. Breadboard is a solderless circuit prototyping platform that is widely used in electronic projects. It is designed to enable us to quickly build circuits and debug and modify them. The breadboard has 2 long rails marked with plus and minus for power connections. The power rails on both sides can support different voltage supplies, making it convenient to provide the required voltage for the circuit. The middle section has holes labeled in rows and columns, with row numbers represented by digits and column labels by letters, helping us position and connect components. The internal connection of the breadboard consists of 4 zones labeled A, B, C, and D. In zones A and D, the holes in each row are connected and are normally used for power supply. In zones B and C, the holes in each row are connected and are used to connect circuit components. A resistor is one of the most fundamental components in electronic circuits. Its main function is to limit the flow of current, and its unit is the ohm. The resistance value is usually represented by color bands, with common types including 4-band and 5-band resistors. In a 4-band resistor, the first 2 bands represent digits, the 3rd band represents the multiplier, and the 4th band represents tolerance. In a 5-band resistor, the first 3 bands represent digits, the 4th band represents the multiplier, and the 5th band represents tolerance. For example, in this 5-band resistor, we first combine the values of the first 3 color bands. Green represents 5, blue represents 6, and black represents 0, forming 560. Next, the 4th band is black, indicating a multiplier of 1. So, the resistance value is 560 ohms multiplied by 1, which equals 560 ohms. Finally, the 5th band is brown, which indicates a tolerance of plus or minus 1%. Next, let's use the multimeter to measure the resistance value of a resistor. Set the multimeter to the resistance mode. Connect the red and black probes to the 2 pins of the resistor. Check the resistance value displayed on the multimeter, and you can see that this is a 10,000 ohms resistor. Compare the multimeter reading with the standard value from the resistor's color bands to ensure the measurement is within the acceptable error range. LED stands for light emitting diode, which is an electronic component that emits light. LEDs have polarity, with the longer leg being the positive and the shorter leg being the negative. The maximum current that an LED can handle is 20 milliamps. So when connecting to a battery, a current-limiting resistor must be placed in series to prevent the LED from burning out. A diode is an electronic component with 2 terminals that only conducts current in one direction. This property allows the LED to function stably and emit light. Now, let's light up an LED bulb in TinkerCAD. First, select breadboard and 9 volts power supply from the list and place them in the workspace. Then, connect the power supply to the breadboard. Next, drag an LED and place it on the breadboard. Connect the anode of the LED to the positive rail of the breadboard and the cathode to the negative rail. At this point, when you run the simulation, you'll notice the LED explodes and a current too high warning appears. To protect the LED, we need to add a resistor. Click on the resistor and change its resistance to 10,000 ohms, then place it in series between the LED and the power supply. Now, run the simulation again, and the LED lights up normally. You can use the components provided in the Clear Robotics kit to try lighting up an LED on your own. A switch is used to connect or disconnect a circuit, controlling the flow of current. When the switch is slid to the left, the 2 terminals on the left, 1 and 2, are connected. When the switch is slid to the right, the 2 terminals on the right, 2 and 3, are connected. Let's add a switch to the circuit we just built. Place a slide switch on the breadboard. Connect it in series with the circuit. After running the simulation, click the switch to control the LED on and off. Similarly, you can use the components from the kit to add a switch to your circuit, allowing you to control the LED lights on and off states. Ohm's law describes the relationship between current, voltage, and resistance. The formula is I equals V divided by R. In this equation, current is measured in amperes. Voltage is measured in volts. Resistance is measured in ohms. This formula indicates that current is directly proportional to voltage and inversely proportional to resistance. In other words, the higher the voltage, the greater the current. The higher the resistance, the smaller the current. Let's calculate the current flowing through the LED bulb in the circuit above. In this circuit, the power supply voltage is 9 volts, and the resistance is 10,000 ohms. Using Ohm's law formula, we get I equals 9 volts divided by 10,000 ohms equals 0.0009 amps equals 0.9 milliamps. Therefore, the current through the LED bulb is 0.9 milliamps. In this lesson, we learned about basic electronic components, including jumper wires, breadboards, resistors, LEDs, and switches, and we mastered how to apply them in circuit building. We also explored Ohm's law and learned how to apply it for calculations. In the next lesson, we will explore the principles and applications of motors, learning how to drive and control motors in a circuit.